Come back up. So this got 6 degrees of freedom. And it was so complicated, it had to have its own computer. So normally this is operated as this base plate is on a table, and I don't think anybody intended to put it on a vehicle. And my question was, could I take something this heavy, still be stable enough and not have it tip over? And it is very stable, and it actually just kind of work. And what we normally do is we'll pick up an object in one place and we'll drive it over another place and drop it off. So it's kind of a cool demo, and I don't want to spend a lot of time on that, but it's worth showing you that. So I'm gonna put the right one, the wrong one. It's gotta go 6. Yes, all of the joysticks are keyed to individual vehicles. Can you imagine if they were all on the same address, what would happen?
Oh my gosh.
Try to drive yours and somebody else's go somewhere else, and so you have complete chaos. So we have 22 vehicles here. You're gonna have, everybody's gonna have their own vehicle. When we get done with the demo, we're gonna let you drive your own vehicle, and then we're gonna go out in a parking lot and we're gonna have a drag race. Wow. So we'll break you up into probably 2 or 3 groups. And the winners of the 2 groups will have a final. Wow. Let me turn this off. Very good job, manipulator. Yeah, it sags a bit if you're not doing it. So before we start, my intention is they have 2 cameras mounted on the front here and a PIR sensor. PIR stands for passive infrared. It means it detects the heat from your body, and I'll explain that later. But the 2 cameras, I'm going to have it in photographing you guys, but I took some pictures of you guys earlier, and so I wanted to no, these are called dogs. And you know what they're called in the United States?
What?
You don't know?
No.
Have you ever heard of manatee?
Oh yeah, manatee.
These are the manatee of the Pacific. So I was out teaching a class in Palau, Micronesia, which is almost to Guam. It's pretty far away, 21 hours by plane. 21. And I went out on a boat with 2 Australian marine biologists, and they had DJI-4 Phantom quadcopters, and they had 3 batteries each, and we spent a lot of time looking for a pod of dugongs. Finally, at the end, we found a male, female, and a baby dugong, and they filmed that. It was just way cool. A really good experience.
What?
So my background is really in deep diving underwater submersibles. So I have 250 dives in deep submergence rescue vehicles, where I used to work at North Island Naval Air Station, and I have 7 of the first 29 sea trial dives of the Japanese deep submergence rescue vehicle. So that was a great experience. I learned to speak Japanese, I taught sonar theory in Japanese, and really enjoyed my 1.5 years in there. So I want to tell you about, give me 1 second, it's got to be a slideshow. So we have 2 types of vehicles here. I've named them Pathfinder just because I like the name Pathfinder, and we always thought that we'd be exploring and pathfinding and finding new ways to use these. I had a friend design this, and he was president of Anyone Can Build Robots, and he mentored me on a lot of things, and one of the things, he designed this vehicle for me, and then he got a job at New University in North Carolina in the computer science department. Really great guy, but I want to tell you the things that are on there. They're described here. These use lithium-ion batteries. That's the power source for everything. The propulsion is from the computer, this is ESP32, through these 4 drivers. Each one goes to a motor, and it's a coupler that connects the shaft of the motor to the wheel, and then the wheel. Do you see a steering wheel anywhere?
No.
So how do you think it turns?
Remote control.
The remote control. That you see right on the top of it.
Yeah, any other ideas on that?
If the wheels can turn like this.
No, that would be a steering wheel, left and right. All right, so this has, the only way it can steer is to make these wheels go forward
Like this.
and these wheels go backwards.
Oh.
So if you want to turn a little bit, you make this go just a little bit faster, it goes to the left. Make this a little faster, it goes to the right. If you do full on here or equal this way and equal that way, it sits and spins. On the front are NeoPixel lights. Those are that, and if I was to turn the power on, it turns the lights on for 2 seconds. If it does that, everything's good and ready to go. From there, you link up the joystick, and then you're able to drive, and you're able to change the lights. So we're going to do that when we get to driving this. Yeah,
Do you use PS4 controllers? Or do you use a different type of controller?
I use a Sony PS3 joystick controller, same as Game Boy. Does it work for you? You know all the buttons, right?
Yep.
Yep.
I'm going to show you how you can tell what button you push
Circle.
I've been
on
playing
the computer.
I play PS4. It's really
Yeah.
easy.
So I'm going to take it down to its element. If you push a button, it's going to say you push the circle or you push the square or something like that. There's also servo drivers, and you saw this manipulator that moved around. Well, that has 6 servos. That's what a 6 degree of freedom manipulator is. This has 4 of them, and so we can put pan cameras and go back and forth, grippers and things like that. Anything with a motor that you want to drive externally. And then we also have a couple of pins that show what the voltage of the battery is and 5 volts. And we use that to connect other sensors and things like that. So the sensors I show you can all be mounted on here and make the vehicle do really cool stuff. So I like what he did, but there were some things that I wanted to improve. So if you look at one of these, so let's turn this on. See, they have individual 12 light emitting diodes. These are light bars that have 8 individual lights. And then I can put them in the 4 corners. And what we do with the lights is we make their car signals. They turn left, or you turn right, or you have regular headlights on, or you have brights on, and in the back, left, right, or tail lights and backup lights. So we integrate all of that with driving the car. So if you're about to turn right, the right lights will come on. So that's kind of cool. The other thing is I have to remove the batteries to charge those. These charged on board. I did a better motor bracket, and so there's just a lot of neat features about this. It makes life easier. So the sensors I'm going to show you, the one we can't do because things not is this passive infrared sensor, and we're going to do various range finders, and there's lots of ways to find out range, and we're going to explore of how that happens and give you examples of what they are. And then you're able to do your pressure and barometric pressure, just like you do in the weather reporting, and then you can do a voltage detector, which tells you the voltage of the vehicle or the voltage of anything you want to check. What is situation awareness? Anybody want to take a guess?
Something bad
Okay.
happens?
When you come in a room, what do? If you've never been there before?
You look around.
Yeah.
You look around.
And you want to assess it, right? Most of what you're looking for is your eyes, but sometimes your ears, or you want to touch things and things like that. So we try to take things in the real world that we want to capture and measure and do something with, okay? Yes?
Kind of like giving them your 5 senses.
It's like doing?
Like giving them senses.
It is, that's what it is, that's what they are, all sensors, all right? Sensors create the situation of where you're at. And those just same words that are on there, that's really good, that's sensing it. And then the computer makes a decision about what to do, and then the computer issues a command. Like, here, let's say we're sensing here, okay, and you see those lights are green?
Yeah.
That's because nothing there, right? I mean, it's doing, that's a range detector and it's looking for obstacles. So if you're driving around and no obstacles, things are green. Right? If you get here, see how they turn to yellow? So we use that to slow the car down if it's going to hit something. All right. Okay, guy. There. It goes red. And if you get too close, we stop the car. And I'm going to implement that in my cars for all these people that turn my race cars into demolition derby. But this is pretty cool. And these are the light bars I was talking about. So the other car has kind of individual lights, the ones over there, and then these have light bars. The neat thing about a light bar is I have one output from here, it goes to all the lights, and so I can program them in intensity and color individually. And life got a lot easier when I changed to that. So I put a big red box around here because it's hard to see. Oops. It's actually hard to see the computer, but we've got one of these right here, and we have one on every vehicle. All right. In here, they're on the back, and on the other one, they're on the side. So these are all the signals. You said you want to find the situation and what's going on. These tell you what the analog things are, you know, and these are what the digital things are. And then there's all kinds of communication ports. So this is a real smart brain, and it also has Bluetooth communication, which it does to the joystick, and Wi-Fi communication it does to the internet. So what we came in here was to have these cameras going, and the output go through the internet, and then to my PC, and then my PC to here. And we just seem to get blocked here, but it's a fun thing, because I was going to drive it around, and as you guys walked in. But I figured you or dugongs, I prefer dugongs. So this, and the camera here, we mounted 2 of them. So this is the camera device, and the actual camera is this tiny little thing here. So this is the ESP32. It's got the same computer in this little thing as is in the vehicle, and then it has a little camera mounted on the other side. So that's pretty impressive for a little thing. So this is what's called a passive infrared sensor, and it senses body heat. So if you look at this, and this beam is split into 2 parts. And so if somebody's walking from this side, it says, aha, I detected a human or some heat. And if he keeps walking further, the other beam says, oh, he's coming in this direction. So they can determine direction. And if either one of them picks it up, that says there's an obstacle in front of us. So that's what an obstacle avoidance sensor is. But it doesn't transmit anything. It has to be passive. Whereas this rangefinder transmits to 8 feet and it gets a return signal. And this is just a much shorter range. Any questions about how a passive sensor works? And does anybody know what infrared means? What?
We talked about it, remember?
Infrared is sun.
Is that Jeffrey or something?
It's like invisible red.
They are invisible to us, and they are part of the light spectrum. Okay, so you have from blue to red. Infrared means beyond red. It's that part of the spectrum. So we can't see it, but that sensor can. Okay, and that, what you see is this little thing has this globe on it, and when it sees something, that light comes on. And then that's the back side of it. So. Now there's a different kind of rangefinder. All right. This is what this one does. It sends out a pulse, and it hits an object, and then comes back. But since it's active, it knows when it send it, and it knows the amount of time it took to come back. So it says, okay, I have to take half that time, because that's the one-way time. And then I convert time into distance. And that's what this is doing. This is set up to be green if it's 40 inches or more, yellow if it's between 40 and 20, and red if it's less than 20. The actual thing, although I showed it like this is a beam form, all right? That's what's really come out of there, is this little beam that's like that. And I've worked on sonar systems, which are underwater kinds of sensors, and when they transmit, they look just like this. So one of these things transmits, and then the other one receives. So these are 3 pictures of green. I programmed this just because I thought it would demonstrate. I broke this up into red, green, and yellow. And so if it's beyond 40, this side only 3 lights go green, this whole bar goes green, and this light turns green. All right. If we're in the middle, 2 in the middle go yellow, that goes yellow, and the yellow light comes on. And red, the 2 over here come on, the whole bar, and then the red LED comes on there. So this is all just playing around with ways to show something. And the light bar, believe me, was the easiest thing to work with, because I changed it from one light bar showing everything to light bar sequentially showing everything. Okay. Now, this is an infrared sensor, and it works like the rangefinder, where it sends out a pulse and then receives it. Except this sensor is a much shorter range. Okay, so we have to shift over for a second. So if you wanted to sense, say, your AC power, or you wanted to see if your battery is charged, or anything else, you can hook this up to anywhere up to 25 volts, actually DC, and then what's written in here is 4,900. Well, that's really 5 volts, so it's scaled at, it's really saying 4.9 something. And so it's actually measuring the 5 volts that's being supplied to it. Okay, so that's a good thing. This says go forward. See, we're on the white stripe with both sensors. So if you're in the white stripe where you want to be, and like in the middle of your lane when you're driving your car, it'll say go forward. All right. And now we've drifted off, and the left sensor isn't seeing anything, so it says turn right. Alright? And now we've drifted over here, and the right sensor's not seeing anything, and says turn left. So if you think about this, doing this very quickly, you actually can start drive your car, and that's what I have on my car. When I put on cruise control, it'll keep me in the lane, as long as I behave myself. And then I program this, if you miss the lane, because what we do is we set these up on tracks, and we have them drive around the track automatically. But sometimes it misses a track, and so it goes off into nowhere, and that's why we say stop. So if you can't follow the track, we want you to stop. Well, oh, and then we have some other things that are really neat things that you can do. Okay. What's really nice about the NeoPixel light emitting diodes is the computer issues an output through this connector, and this connector then jumps over to this one, which then jumps over to this one, which then jumps to this one. So all you do is one pin out of the computer, and you are telling every one of these lights whether to turn on, how bright, and what color. And this is called the simple test, where we go through some standard testing. All right, we try different colors. So there's some yellows. So it's just the green. It just says, okay, all my lights. So we do this when we test out a car. We've never used it before. We run the NeoPixel simple test. But if you really want to get fancy, we combine 4 different programs in there. All right. So what you see on the back, front, you actually see on the back as well. So it goes through the different colors on the lights all at once. All right. Then we're going to go into, that's kind of neat, some flashing lights. Nice. And then it's going to stop and pause and do this a couple of times. This is called the rainbow check. And then there's the marquee rainbow check, which combines all of the stuff. So it's varying the intensity, all from one pin of this computer, which is kind of amazing.
Can you make the American flag out of the colors?
You can do every color in the spectrum with this. You can do white. Now, the register rate colors is, if you look at the color spectrum, white is all colors. So if I send a command to red, blue, and green as full value, what comes out is white. And then I can send a value that 255 and it'll come out yellow. All right, and if I send 2 of them as one is yellow and one is green, one blue, it'll come out green. So that's how you mix these colors, just by commands. So you're actually sending 3 separate commands to each light of how much green, how much blue, and how much yellow. And the color spectrum is really clever about taking that and giving you the color you want. Red lights flash, just like everything else. What I like to do is power a thing up, flash lights for 2 seconds, and it tells me that everything's working fine. It gives me a lot more confidence that it's going to do what I want it to do. So you've used the Sony joystick before. You like it. It does a lot of things for your Game Boy, right? Do you know what each button is doing? I mean, obviously you don't. I don't. Nobody can know. But how do you make one of these make a vehicle do what you want to do? All right. If you hit the X, it says you press the X, you let it up. You hit the square. All right. You hit the circle. You hit the triangle. You hit the D-pad, the upper one, the right one, the bottom one, the left one, either of these buttons on the back, or the toggle. Or if you want to drive that manipulator, you do it with the right joystick. and you turn that left, right, up and down. So that lets you have 2 degrees of freedom on a joystick, and then these analog switches are the other 2 freedom. Okay, so you can have a pan and tilt camera, and then on the camera you could have a zoom function. So you could be driving around and scanning all around. But that's what everybody who develops your Game Boy programs has to know, those codes, and that's what the program does. It says, all right, you're projecting through Bluetooth to the computer, and the computer knows the code that you're sending and then displays that. That is, that's pretty much the demonstration I wanted to show you. Do you guys have questions? Well, is anybody interested in driving a car? I'm going to explain a little bit about it. Okay, on the cars you're going to use, because they work, the power system works just a little bit, but on this one, the power is up front, and just like I said before, for 2 seconds the lights come on. You put that down on the floor, and then you press the P3 button, okay, and the lights will flash, and then they'll go on, one will go on steady. That means you're linked. That's a Bluetooth link to here, and it says, oh, I can make it go forward, back. Now we were talking about turning. There's no steering wheel. All right, so you can spin it, or you can turn it just a little bit. So when you're doing your drag race, they tend to drift off, and they'll only accept one command at a time. So you can't diagonally go and do this neat turn. So it's very much like a tank. If you've ever seen all of these tanks, they have treads, and that's how they steer. You never see a steering wheel on a tank. But what's nice is you can interpret that joystick and say, oh, I want to turn on all the lights, or I want to turn them off, just by hitting various buttons. Or I can say, I'm going to turn the right lights on. Oh no, I'm going to wink with my left eye. Okay, I can do that. So that's it. You've got, steering is just like you would think, forward, back, left and right. This is all the lights, and this is all the lights off. This is the left lights, or the right lights, yeah, and this is the left lights. These 2 buttons on here. That's all you need to know. There's a lot of other things you can do, but this is what this program does.
What do we do first class? We need to...
What I'd like you to do is pick a vehicle, right? And now we have 6 vehicles on the left go into one box, and 6 vehicles on the right. So there's 1, 2, 3, 4, 5, 6. It's separated here. If you pick up one from the left side, please put it with its joystick back on the left side. If you pick it up from the right side, put it back with its joystick. And that gets me in the right box, and I keep track of all this. So who would like to be the first person to show us? How about you?
You go under somebody's chair.
This forward, or back, or left, and go forward. Right. Now, then press the X. All the lights will come on. Press the square. All right, press this top one. All right, and press this one here. Those are all the commands. Have at it.
Bye.